Hello, welcome to the third video on the May and June series 2019 for Edexcel higher tier. So what I'm going to be doing here is talking through the entire paper. For some questions I'll show you a variety of methods. For other simpler questions I may just show you the one. So as ever, please as you're watching this do make notes as you're going along and do just check your answers against my own. If you're just watching the video then you won't be getting as much out of it. So as well as that, because it's a calculator paper, have your calculator handy. I would always recommend the Casio. I'm currently using this one here, the ClassWiz, which is very versatile and can really help. So I'd recommend having a calculator as a minimum. If you're going to get any calculator, I'd recommend this one personally. Okay, without any further talking about anything else, let's just get started and have a look together at question 1. Question 1, we have a Venn diagram, and we need to just complete it for part A. So for curly E, just means everything. Okay, so E just means all the things we're going to be putting into our diagram. Okay, so the only things inside this Venn diagram are going to be the numbers from 1 to 9. So that curly E just means everything inside the diagram. A means everything in circle A, B means everything in circle B. I would always recommend starting with what's in both A and B. In other words, what items, if any, are in this overlapping section here in the middle. And so what we're going to have a look at now is the items in set A and set B. By doing the overlapping bits first, we make sure we don't double count any elements. So 1 is in A but not B, 5 is in A but not B. But if you look here, 6 is in both, 8 is in A but not B, but again 9 is in both as well. So 6 and 9 are in both. So what we can do here is include 6 and 9 in this middle section. And if it helps you, this is completely optional. You might want to just tick off 6 and 9 there to make sure you don't double count them. Next, we can consider all the things that are just in this A section here. So just A, nothing to do with B. So have a look and you consider what these things are, and hopefully you've got it by now. I'll just finish colouring in quite quickly. So having a look at A, okay, the set A includes 1, 5, 6, which goes here, 8 and 9, which, as we showed earlier, goes in the middle. And so the items which are only in A and nowhere else are the 1, 5 and 8. So we include 1, 5 and 8 in this section here. Again, as I said you might want to do, just cross off 1, 5 and 8. Next, we can consider the items which are just in circle B, but not in the overlapping bit. And as you can see here, that's just this 2. So if I just were to quickly colour this in, I apologise if you're finding this slightly tedious. I'll make a bigger brush so I can get it done quicker. I might go over the lines, but it doesn't really matter too much because I'm just trying to do is to illustrate to you how to fill in the Venn diagram. So, because only in B is 2, we just fill in this bit with a number 2, and a common mistake now is to think we're done. However, if I cross off this 2 here, you will see that we still haven't included 3, 4, and 7. So the numbers still not included, in this case 3, 4 and 7, lie outside of these oval regions, but inside the rectangle itself. And so in any order, we put 3, 4 and 7 on the outside of these regions, but inside the rectangle itself. Part B, we're told that a number is chosen at random from the universal set E. For B, we need to find the probability that the number is in the set A NB. Now this isn't really an N, that N means the intersection of A and B. I'm going to explain this right now. The N means A and B at the same time, simultaneously. So, for example, the intersection of A and B would mean all items in this overlapping region here. And so, in other words, that symbol relates to this region. So what we need to do next is to remind ourselves of what we had from part A, and then we'll be able to see what numbers were in that region. This is what we had from part A, and so in the intersection, you can clearly see there are two numbers. So we can therefore reason out, because there's two numbers literally out of a total of 9 in A intersection symbol B. This bit here we don't need to write for the examiner, this is just me to give you a bit of detail in terms of where the answer comes from. 2 out of 9 numbers were in the intersection. That means that if we were to pick a number at random, the probability that we picked a number which is in the intersection of A and B would be 2/9, because 2 numbers out of those 9 are in the intersection of A and B. That finishes off question 1, so we can now move on to question 2. Question 2, Katie's investing £200,000 in a saving account for 4 years. Lucky Katie, that's a lot of money. The account pays compound interest at a rate of 1.5% per annum. Now, per annum is just an old-fashioned way of saying per year. We now have to work out the total amount of interest Katie will get at the end of 4 years. We now need to consider a couple of things. Firstly, we need to consider what percentage of itself any number is before any change is applied to it. And that, of course, is 100%. We always start with 100% of a number. So, interest in bank accounts is a good thing. It increases the value of the saving. This compound interest is paid at a rate of 1.5%. So, this is the original amount. We now add on 1.5% of that. That would give us 101.5%. So after every year, after the interest is added on, the amount ends up being 101.5% of its original amount. But we could do this as a decimal, because in this case decimals are easier to work with. So if we just take this number here and convert to a decimal, what we'll have is the number in decimal form. So 101.5. If I press Shift %, or hopefully, to change from a percentage to a decimal, we divide by 100. Either way, we'd get, press SROD, 1.015. And this number here is crucial. That's the number I like to call myself the decimal multiplier. There is a slower method for compound interest questions where you can draw a table. I'm just showing you the one method here today. But the decimal multiplier tells us what to multiply the initial value by for each time period the interest is given. Here, the interest is given every year, and there's 4 of those years. And so the interest is going to be added 4 times. So what we do now to work out the total amount after 4 years is we take the starting amount, which as we can see here is £200,000. So we take £200,000 and we multiply that by the decimal multiplier, and because it's for 4 years and the interest is going to be added on 4 times, we take the decimal multiplier and raise it to the power 4. And so just so you can see where these numbers are coming from, that's the starting amount multiplied by the decimal multiplier itself to the power of the number of times the interest is added on. And that's all there is to it. So for now, we just calculate this and see what the calculator gives us. So I'll just make the screen bigger if you'd like to see it. There we go. So £200,000 multiplied by 1.015 to the power 4. We get this awfully big number. So 212272. Write it all down carefully. 212272. 0.71. So with decimals and money, 2 decimal places means the pennies, so we can ignore that 01 essentially. So £212,272.71. Now this question needs to be a bit careful. We were asked for the total amount of interest Katie will get at the end of the 4 years. Okay, so the total amount after 4 years, that means starting amount plus the interest. The interest is just the difference in between what we end up with and what we started with. And so therefore, the interest Katie gets is going to be the final amount, which is 212272.71 minus her original 200,000. So if we do that, minus off 200,000, we get this. So we get £12,272. Then of course for 71 pence at the end. And that's question 2 done. £12,272.71. So let's see question 3. Question 3, we've got heights about 80 plants. Part A is very straightforward, in fact. Find the class interval that contains the median. Okay, so what is the median? Well, the median is essentially the middle value. Now there's 80 plants. So imagine these put in order of height. Then what we could say here is the middle one would be halfway along roughly. So 80 divided by 2 is 40. So therefore, the median, because this is a continuous data table, height is continuous, the median will just be the 40th value. So to find out where the 40th lies, we just need to do a cumulative frequency running total. So start with 0. I'm just going to label this CF for cumulative frequency. So start with 0 and add up as we go. So 0 plus 7 is 7. 7 plus 13 is 20. And we're going to keep going until we get to the first value, which is at least the median. So 20 plus 14 is 34. Still not at 40 yet. 34 plus 12 is 46. Now, we have gone beyond the median. So what we can say here is that 34 and 46, the median is in between these. Because 40 is in between 34 and 46. Now, if you wanted to carry on, I may as well just do for completion. 46 plus 16 is 62. 62 plus 18 is 80. You always end up with a total number of frequency values you have. Anyway, because the median is in between 34 and 46, we can then conclude that the median must be in this class interval. So we just conclude by saying, therefore, or just median lies in the interval from 40 to h to 50. And that's part A done. Let's have a look at part B. We have a grid, and we have to draw a frequency polygon for the information in the table in part A. So just reminding what we had from part A, we had this table here. So all we need to do really now is to think about this as a line graph, essentially, and we plot from the midpoints of these intervals. So I'm going to adapt this table here. I'm just going to add on an extra column for midpoints. So from 10 to 20, the midpoint there is going to be 15. From 20 to 30, halfway between 20 and 30 is 25, 35, and so on. So the first point we plot is we go along to 15, because that's the midpoint, and then up to 7. And so 15 and up to 7 would be here. Then we go along to 25 and up to 13, so that's going to be this point here. Then it's 35 and 14, so 35 all the way up to 14 would be this point, as so. 45 and 12, so 45 would be this point here, then up to 12, that's 11, that's 12. Then 55 and 16, so start at 50, go along to 55, so 1, 2, 3, 4, 5 is here, then up to 16, that's 15, another 2 goes to 16. Then finally 65 and up to 18, so this one, the final one, would be there. Now, by doing that, we're only halfway done. So to finish it off, what we do is we get a ruler and join these points with a straight line from point to point. And that makes what's known as a polygon. And that will do. That's okay. So question 3b is now finished. So question 4. Question 4, Sean apparently has drawn a time series graph to show the numbers in thousands of visitors to a fun park like so. So this is a very strange graph indeed, and to write down 2 things that are wrong or could be misleading with this graph. Now importantly, you need to be confident that there's often going to be more than the number of things you need to list. Here you could list several. Okay, so it might be worth pausing the video here and having a look and just thinking yourself, what is wrong with the graph. And being wrong could also be interpreted as what is misleading, what is unclear, what is confusing. It doesn't need to be a categorical error, it could just be what could make this graph much better. So I'm just going to list all the points, versions of them you could write down to obtain a mark each time. It's 1 mark for each relevant point, up to just 2 points. So just write any 2 from the following responses. So the first one, I would say, is the points should be joined with a straight line. Okay, each time he made an observation about the number of visitors to this park, it's just a one-off observation. It's a snapshot in time. It's not like if you have a stopwatch or you're recording something continuously. Each point here is a discrete, one-time only observation. If it's discrete, they should be joined with a straight line. A curve would imply that he's measuring these visitors continuously all the time, which he's not. And also, it's implying that he knows what's happening between one point and the next, which he doesn't. So if anything, these should be joined with a straight line, not curves. That's the first thing to mention. Another thing you could mention is the vertical axis doesn't start from 0, and so this makes it very misleading indeed. So for example, it looks like from this point up to that point, the number of visitors is more than tripled if you're just looking at the graph or you weren't particularly mathematically inclined, whereas actually it's only gone from 7 up to 9.8, which isn't doubling at all. And so because it's a broken scale graph, not starting from 0, that can be misleading. It's not wrong, but it falls into the misleading category. Don't know if you noticed this, well done if you did. 9.5 is missing on the vertical axis. 6, 6.57, the increments are 0.5. Each 5 little squares going up is worth 0.5. So 7.5, 8, 8.5, 9, then it jumps up to 10. So that is a mistake. So that's one I would mention personally. Next up, the x-axis labelling doesn't really make sense. So we're not told what 2, 3 and 4 mean, which doesn't really help at all. We're not told what 2, 3 and 4 mean. Does it mean the second month of 2016, the third month, the fourth month? Or does it mean the second quarter of 16, the third quarter or the fourth quarter? We're not told clearly, and that makes it a very bad scale. It's not labelled, and therefore it is unclear and I think misleading. And the final thing you might want to say about this is that 2 is plotted for 2017 and 2018, but it's not been plotted for 2016. So for example, this point 2 here, as you can see, it's been plotted for 2017 here, there's the 2. It's been plotted for 2018, but for 2016, there's no point, so why hasn't that been plotted? It's inconsistent, and again, I'd argue that makes it quite a poor graph indeed. So you've got 5 main things to pick from. Pick any 2, and you've picked up full marks for question 4. So let's have a look now at the next one, question 5. Question 5, we have an angles question. So we have a hexagon, not a regular hexagon, but it does have 6 sides. This hexagon's got 1 line of symmetry, so what I'm going to suggest here is that we add this in just so we can sort of picture what's going on. So what I'm going to do here is just add this going down the middle, like so. Now, we're given all this information, so FA equals BC, and so that side is equal to that side. EF from here to here is the same as CD, and it's been labelled here. The dashed lines means both sides are the same length. So that gives us the line of symmetry being down the middle, because the left-hand side is the same dimensions as the right. So, although I would say it's fairly obvious judging by this here. So, what we need to know is how many degrees there are inside a hexagon. So what I'd suggest is starting with a triangle. And so, oops, that was a tiny mistake. So the total degrees in a triangle is obviously, I hope you know, remember, it's 180 degrees. And there's a formula for this, which I'm going to explain to you. I'm not going to go into depth. Your teacher may or may not have explained this formula. So for any n-sided shape, for an n-sided polygon, I'll explain this without using the formula as well, so don't panic. Total degrees is always going to be 180 multiplied by the number of sides minus 2. Now I think doing it pictorially will make more sense. So what we can do here, we can imagine the hexagon as being composed of a certain number of triangles, and we can work it out for ourselves. So if I were to take, for example, this point B, I could go from B to F, that's one triangle. Could go from B to E, that'll make a second triangle. I could also go from B to D, that would make a third very big triangle. And then there's nowhere else to go, because on the far right hand side I've got a very thin looking triangle BCD. And so as you can see here, within this hexagon you can think of it as being 4 triangles glued together. So 1, 2, 3, 4, and it would work no matter what point you started from. For example, I could have picked point E, gone E to C, that's my first triangle, E to B is my second one, then E to A is a third one, and the fourth one over here. So there's definitely 4 triangles in a hexagon, if you like. And not by coincidence, 4 is 6 minus 2. So for a hexagon, total degrees in a hexagon, total of all the angles, is 180 degrees per triangle, and as we've seen, there's 4 such triangles inside the hexagon. So 180 multiplied by 4, that's going to give us 720 degrees. And that's going to be key to answering this question. What I'm going to suggest we do now is we fill in this extra information. So using the symmetry, if that's 117 degrees, the angle at A will be 117 degrees as well. Angle BCD, we're told, is 2 times angle CDE. Now from B to C to D, that's this one here. So what we can do first of all is label on angle BCD, which is this. And that's going to be the same as the angle at F, just by the symmetry of this hexagon. We're told it's 2 times angle CDE. My suggestion is we're going to call angle CDE angle X. It's some angle we don't know, so let's just call it X, because, well, lots of things in algebra if we don't know, we just give them the letter X. So I'm going to call CDE, the angle at D, I'm going to call that X, and by symmetry, this angle here at E will be the same. So I'll just colour code this in. And then, if the angle at D is X, we're told that angle BCD is double that. So in other words, if these two are X, then the yellow angles are 2X. Now we now know the total number of degrees for a hexagon, either using this formula or just thinking of it as 4 triangles glued together. The total degrees for the hexagon is 720. So we can use this to our advantage, and we are going to. I didn't quite fill in. So using this information, if I just drag it over there, if we add all these angles together, it needs to come to 720. So we can now get an equation in terms of x, and from that we can work out angle AFE. So we need to remember that AFE as well is going to be the same as angle BCD, which is going to be double angle CDE, which is the same as angle FED. Anyway, so let's do this equation. So total of these angles, we've got 117 plus 117. We've got 2x and another 2x, x plus x, and we're told that has to be equal to 720. So that's how we start it off. And 2x plus 2x, x plus x, and then 117 plus 117, which I've not called in, but I could if wanted. That's going to equal 720. Now, as your teacher's probably told you, if you can do, you need to simplify algebraic expressions. So 117 plus 117 just means 117 multiplied by 2. So if we work that out, we get 234. So 234. Now how many x's do we have altogether? 2x plus 2x is 4x, plus x plus x, that gives us plus 6x in total. That equals 720. We can now begin to solve this equation, so we can rearrange and make x the subject. So first of all, if we subtract 234 from both sides, we'll get 6x on its own. So 6x will be 720 minus 234. So 720 minus 234, that gives us 486. So 6x equals 486. We can work out what x is by dividing both sides by 6. If you're particularly astute, you might be thinking, but I want 2x, can I not just divide by 3? You can do. It's just a habit of mine to find out what one unknown is first and then double up or multiply to what we need after. But yes, because we want AFE, which is 2x, you could at this stage just divide by 3. That would be fine as well. But anyway, if you didn't, we can just divide through by 6 and then we can see what we get. So 486 divided by 6 gives us 81 degrees. So x equals 81 degrees. Therefore, angle AFE, which we want to find, which is 2x, that's going to be 2 multiplied by 81 degrees. 2 times 81 would give us 162 degrees. And so, we're finally done. That was, definitely can see here, the question difficulty is jumping up slightly, even at question 5. But we've done it now, so let's move on to the next one. Question 6. Jeremy's got to cover 3 tanks completely with paint. So, what tanks are they? Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 meters and a height of 1.8 meters. He's got 7 tins of paint. Each tin paints 5 square meters. Has he got enough to completely cover the 3 tanks? You must show how you get your answer. Okay, now this is a question about surface area. We don't paint inside the tank, so it's not a volume question. We paint the surface, so it relates to the surface area. Now each cylinder's got a top and a bottom. So the top is going to be circular, as you can see, like so. And we have to paint the sides as well. Okay, so the sides are going to be the curved surface. So just paint the top and the bottom and this surface. The first step would likely be, if we're trying to solve this question quickly and efficiently, would be to calculate the total surface area. So let's do this now. So the total surface area that's the top plus the bottom plus the curved surface. So the top and the bottom are both circles. The curved surface, well, we need to find out what that is in a moment. So one thing we should know is the area of a circle. So the area of a circle is going to be pi r squared. So we can write this down straight away. The bottom will be the same size circle, and the curved surface area is always going to be the circumference of the circle, which is 2 pi r, multiplied by the height of the circle. Now I'll fill in what these values are in a second. So if you're wondering why the curved surface area is 2 pi r h, and your teacher may not have mentioned, or if they have, it may have been something you've forgotten, there's a nice illustration which explains very neatly why. You can imagine a cylinder as being a piece of paper sort of rolled up, and then imagine unrolling it. You'd find that the top edge from one end to the other where it meets would be just the length of your rectangular piece of paper, and the height would be the width of your piece of paper. So just to illustrate the total surface area of a cylinder, I've got this illustration for you to think about for a moment before I remove it. Okay, so if you imagine unfolding like so, you can see this rectangle unfolds. It's 2 pi r along, and it's h wide. So the area of this is 2 pi r times h, and the two circular ends, you can imagine being laid flat, they have an area of pi r squared each. So we've got two lots of pi r squared plus 2 pi r h. So I think that's quite a nice demonstration, which makes it quite clear. I'll cover it up for now. At this stage, we can add in the information to our diagram. And so first off, we need to calculate the radius of our circle. So radius just means from the middle to the end. So we're told that the diameter from one end all the way to the other is 1.6. The radius is half of that. The radius will be 0.8 meters. So total surface area is going to be pi times 0.8 squared plus another pi times 0.8 squared plus 2 times pi times radius, which is 0.8, times the height, which is 1.8. So let's just work out what this is going to be. So this is definitely a calculator question, no doubt about it. So to get the pi button, if you press shift pi where it says x 10x, you get pi exactly. So pi times 0.8 squared plus another shift pi times 0.8 squared then plus 2 times shift pi times 0.8 multiplied by 1.8. We get 104 over 25 pi, which you can leave like that if you want to. Alternatively, you can get it into a decimal by pressing this, and give it to many more decimal places than what you think you might need to make sure there's no rounding error creeping in at the end of the calculation. So 13.069, I'd say, to give it to at the very least. So 13.069 meters squared. So that's total surface area for one tank. How many tanks are there though? Well, we're told here that actually there's a total of 3 tanks. So we're going to need to take this value for one tank and multiply by 3. So for 3 tanks, for total surface area to be painted, that's going to equal 3 multiplied by 13.069. So times this 1 by 3. 39.207. Square meters. So Jeremy's got 7 tins of paint, and each tin of paint covers 5 square meters. So from here, Jeremy is able to paint 5 square meters for one tin, but he's got 7 tins, so he can paint a total of 7 times 5. He's able to paint 35 square meters worth of surface. So importantly here, this area that needs to be painted is greater than the amount of paint Jeremy is able to paint. So therefore, he does not have enough paint. You'd need another 10. And showing these steps is crucial in terms of getting full marks awarded for this question, because it does say you must show how you get your answer. If the answer is he doesn't have enough paint, or you can just say no, he doesn't have enough paint, with this working here to back you up for that conclusion. You can't just put no and get full marks. It amazes me people still sometimes think that you need to back up your conclusion with solid mathematical working and evidence of process. Question 7 is just a case of checking, can you use your calculator confidently and correctly? So with practice, this should be very straightforward indeed. I'll even tell you how to do this using a slight, almost cheat in a way, a legal cheat, dare I say, where the calculator will tell you how many different figures for you. So first of all, we should make sure we have this written in exactly the same way, which is one of the very reasons I recommend this class whiz, because we can type in an expression exactly how it looks pretty much without having to worry about how to format how we type it in. So we're going to aim for this looking exactly the same on our calculator as it does in the question. So the first thing we do is type the square root button. So next we have a fraction, so type fraction button here. Now we can just start typing along the top. So it's 2.5 multiplied by sine, so press sine, then 43. Now close off the brackets just so it's one complete step. Then we scroll down, type 8.2 squared minus 50.5. Press equals, and we get this, 0.319. So obviously the answer goes on more than that, so let's just think about this. So it's 0.319. 1, 9. The number does go on a bit more, so it goes on 1, 4, 1, 9, 8, 5, 5. 1, 4, 1, 9, 8, 5, 5. Now, significant figures means we start counting from the first non-zero number. So the first zero is not significant, but the first digit, which is non-zero, is. So that's the first significant figure, that's the second, that's the third, and so we're going to cut off the number after that point. So we're going to be left with either 0.319 if the number doesn't round up, or 0.320 if the number does. So how we select if a number rounds up or not is by looking to the digit next door to the last significant figure we want to keep. So next door to the 9 is a 1. You should remember if it's 5 or more, we round up. If it's not more than 5, we don't round up. So 1 is less than 5, so that 9 does not round up, it stays as it is. So our answer therefore is 0.319. And I will give you a slight tip, which might help. I would avoid over-reliance on the calculator if you can, but I'm going to give it to you here, this tip, so you can use or ignore it as you wish. So if we press Shift Menu, and we go down to number 3, number format, press option 3. Now SCI mode means scientific mode. It gives you a number in standard form. But more than that, we can select the number of significant figures we want the number to come out to be. So if we want 3 significant figures, we type in 3, then press equals again. So obviously we get times 10 to the minus 1. That just denotes that the decimal is actually over here rather than there. But the 3, 1 and the 9, as you can see, they are the 3 significant figures. So that's a very nice tip that basically tells you the numbers you're going to pick are just the 3, the 1 and the 9 and no more than that. To get back to normal mode, by the way, we press Shift Menu again, number format, go to Norm, and I prefer normal mode 2. So that's question 7. Let's now have a look at number 8. Number 8, have a right angled triangle. Big tip here is going to be either Pythagoras or standard trig. So Sarah wants to find the length of BC. So she's done this here. BC squared is AB squared plus AC squared. And she's squared both sides, added them together, and square rooted to get 10. What mistake has she made? I think you could do far worse than just doing this question yourself correctly, and then comparing your own correct version to Sarah's incorrect version to highlight what she's done wrong. There might be several options. So how would we find BC? Well, we'd use Pythagoras, wouldn't we? Pythagoras applies when we have a right angled triangle. We know 2 sides, we want to work out the third. So it's always the hypotenuse squared. So AC squared, the hypotenuse is always the side opposite to the right angle. So in this case here, the side opposite to the right angle is AC. So that's why we know that's the longest side. Normally you can just tell by looking at it, but if you're ever unsure, it's always the side opposite the right angle. So AC squared will equal the other 2 sides squared and added together. So AC is 8. So 8 squared equals AB squared, which is 6 squared plus BC squared. So BC squared would actually be 8 squared minus 6 squared. Now then we can square it both sides. So 8 squared is 64, take away 36, so 64 take away 36. We could do that ourselves if you wanted to. So what is 8 squared minus 6 squared? We get 28. So 28 equals, equals BC squared. I wrote 6 there, that's a bit strange. Therefore BC is going to be the square root of 28. We could give this to, we don't need to complete the question, but just for the sake of it, square root of the answer, 2 root 7, it's about 5.29 centimetres. So we've gone above and beyond now, but we can hopefully see what the main mistake is. I'd be saying the mistake is at this step here. She did 8 squared plus 6 squared. She should have done 8 squared minus 6 squared. And I just add that in your own words. So Sarah did 6 squared plus 8 squared. She needed to do 8 squared minus 6 squared. Okay? Or you could just start from the first line. So if I rearrange this first line here by subtracting AB squared from both sides, we'd see that BC squared equals AC squared minus AB squared. So you could write that down instead. Or we could put Sarah needed to write that BC squared is AC squared minus AB squared to begin. So her first line's a mistake, but the first mistake in terms of the calculation you can see is this one here. But of course, if she had set it out to begin with correctly, she probably wouldn't have made such a mistake. Part B is similar. It's trying to identify and explain a mistake to the examiner. So 8B, Roy's trying to enlarge triangle PQR with centre C and scale factor 1.5. He draws triangle X, Y, Z. Explain why his diagram's not correct. Well, there's a few ways of doing this. What I'd suggest we do is just to consider what the scale factor tells us. And so the scale factor of enlargement, scale factor tells us what each side of the original shape has been multiplied by. For example, if the scale factor was 2, that would mean each side gets doubled. If the scale factor was 3, each side gets tripled. If the scale factor was a half, each side's been halved. So let's have a look at PQ. So PQ equals 2 units. And that relates, that corresponds to XY. 1, 2, 3, 4, 5. XY is 5 units. So from that, if the scale factor was 1.5, you could say 2 times 1.5 is 3, but XY is obviously more than 5, so therefore the scale factor is too big. Is greater than 1.5. So that's one way you could explain it. Or, a different way, one way of explaining the scale factor is like this. You could, however, calculate the scale factor directly. So you could say the scale factor is the new side divided by the original side. It's a ratio of new to old. So looking at PQ and XY, the new side is XY. So that's 5 units, that's 5 squares. The original side, PQ, is just 2 squares. So if we did that, 5 divided by 2, we get 2.5. And then we could say, that's why Roy's diagram's not correct. So Roy has used a scale factor of 2.5 or 2.5, not 1.5, which is what he was trying to do. Just be careful. You could draw the diagram yourself and do it correctly, but a diagram on its own is not enough. If you're to do a diagram, you'd have to draw a diagram yourself and then compare your correct diagram to Roy's incorrect diagram. For example, saying, as we can see, Roy's drawn it too big, his scale factor is too great, or something along those lines. So just doing it correctly wouldn't be enough. You'd need to explain, along with the diagram, what Roy has done wrong. Question 9. These questions students tend to struggle with. So a company has to make a large number of boxes. The company has 6 machines. All the machines work at the same rate. So I'm going to just take the fact this company has 6 machines. Okay, so if I just say here, machine, we've got, let's call it A, B, C, D, E, and F. When all the machines are working, they can make all the boxes in 9 days. So again, think about all these machines. If each of them worked 9 days, that's 9 days for 6 machines. So to make all the boxes, all boxes made equals 54 days of machine work. I'll call that one machine's work, in fact. So the key thing is, for one machine running non-stop, it takes one machine 54 days. If it takes 6 machines 9 days, that's a total number of days of work of 54 days for one machine. Now, not all these 6 machines are working all at once. So for example, day 1 only half of them are working, day 2, 4, 5, and all of them come online after that. So work out the total number of days taken to make all the boxes. So we need 54 days of one machine's work. And so here we've got 3 days. So 3 machines working for 1 day, that's 3 days of one machine's work. Then 4 days of one machine's work. Day 3, 5 machines are working, that's 5 days of one machine's work. So forgetting the other days, so far from here, 3 plus 4 plus 5, just for day 1 through to day 3. 3 plus 4 plus 5, that comes to 12 days of one machine's work. So we just did 3 plus 4 plus 5. Now we need 54 days. So then 54 minus 12 will tell us how many more extra days of machine work we need. 54 minus 12 equals 44 days still needed. Okay, here though, we've got all 6 machines working for all the other days. So we need another 42 machine days. Okay, so if I just say here, for example, how many extra days? Let's say they're all working for the number of extra days, which is X days. And that still needs to be 42 days of work in total. 42 days worth of work. So what we can say here is that 6x needs to be 42 days worth of work. So therefore, the number of extra days on top of these first 3 days would be 42 divided by 6, which is 7 extra days. So the total number of days needed to make all the boxes would be these first 3 days plus these 7 extra days. So that's 3 days plus these extra 7 at the end. Worked out that's 7 now. 3 plus 7. We need 10 days in total for these machines to be working for. I would, however, like to show you an alternative approach to question 9, which might make more sense to you. It's longer, it's not as efficient, but it will get you there in terms of getting to the correct answer. So let's have a look at an alternative way of thinking about this. So using this alternative, it still hinges on knowledge that we'd need 54 working days for if just one machine were working. So 6 multiplied by 9 days working, 6 times 9, we still need to work out that we need 54 machine days. 54 days where one machine would be working flat out. So what we can do here is we can consider how many days and also how many machines are working each day, with getting up to a target of 54 working days in total. So we could do like a build-up table. So like I said here, 6 machines, and it would be complete after 9 days. So the number of machine days we need, where what I mean by a machine day is just one machine working all day. So we'd need 6 times 9, 54 machine working days, which, just to be shorthand, I'm going to call machine days. That's our target. So day 1, only 3 machines are working. So I'm going to say the machines that are working are just machine 1, 2 and 3. So that gives a total number of machine days of 3. Just 1, 2, 3. Day 2, we're told 4 machines are working. So I'm going to say that's 1, 2, 3, and also then machine 4 joins in. That's 4. And what I'm going to do down the side is a running total. Cumulative frequency of machine days, essentially. So we had 3 and 4, so that's 3. 3 plus 4 is 7. We're not at our target yet, so we carry on. Day 3, we're told 5 machines are working. 2, 3, 4, 5. That's another 5. Then from then on out, each and every machine is working for all the other days. So day 4, day 5, day 6, day 7, and so on. Each and every machine's working. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You can obviously do this yourself much quicker than I'm doing it here, just by not talking about it and just cracking on, but you'll hopefully see the process. So that's another 6. 6, 6, 6. So let's just see where we are with our running total. 3 plus 4 is 7, plus another 5 would be 12. And just keep on adding 6s. 18, 24, another 6 is 30. Another 1 would be 36. We're not at our target of 54 yet, so go again. Another 8. 8 days. That's another 6 complete days of one machine working. 36 plus another 6 would be 42. You can see that's building up in the 6 times table. So another 6 would be 48. Another 6 would be 54. So reach our target of 54 after not 9 working days, but 10. And just fill in the table so it looks nice. We could go 1, 2, 3, 4, 5, 6. That's another 6. And finally, 1, 2, 3, 4, 5, 6. Gives us our final 6 hours needed. Brings up to 54 in total, which is our target number of machine days. And we reach 54 after a total of 10 days. So using a different approach, you can say that therefore 10 days are needed. So a completely different approach. I think that one's a bit nicer in a way, just takes a bit longer, but with practice using this method, you can get to the answer still surprisingly fairly quickly. Question 10 is about interest and accounting. So Maria invests £8,000 into an account for 1 year, and at the end of the year interest is added. She pays tax on the interest at a rate of 20%, and we're told she pays in total £28.80 worth of tax. Now this is the key bit of info. We need to work out the percentage interest rate for the account. If she pays tax on it, and she gets taxed £28.80, we can therefore say that 20% of the interest she got must have been £28.80. Now, we could do working out all of the interest she got, her actual total interest. Now, the total of any amount is 100% of itself. So how can we go and build up to 100% of the interest? Well, how do we go from 20% to 100%? If you're not sure, we can do 100 divided by 20, but essentially we just multiply by 5. So we need to multiply both sides of this by 5 to work out the total interest she got. So £28.80 multiplied by 5 that gives us £144. Now, percentage interest, we can now work this out. Now, normally it's framed as percentage change. So, generally speaking, whatever percentage change happens to be, percentage change, in this case it's percentage interest, it's the change divided by the original. So in this case, we're talking about the interest. That's what's changed in terms of her amount in the account. It's the interest divided by the original, which is a fancy way of just saying starting amount, multiplied by 100 to change it from a fraction to a percentage. So we've now worked out what the interest she got was. The interest was £144. We also need to know what she started with in her account, which we do know, it was £8,000. So we have all the ingredients here to work out what her percent interest is. So it's going to be 144 divided by 8,000 multiplied by 100. So fairly straightforward now, really. Just button bashing on the calculator essentially, and that'll tell us what we need to work out. So 144 over 800, sorry, over 8,000 I mean to say, times 100 gives us 9/5, which is 1.8. So we've got 1.8%. Question 11. In May 2019, the distance between Earth and Mars was 3.9 times 10 to the 7 kilometers. And in May 2019, a signal was sent from Earth to Mars. Assume that the signal sent from Earth to Mars travelled at a speed of 3 multiplied by 10 to the 5 kilometers per second. That's the speed of light. How long did the signal take to get to Mars? So how long means time. We've got a distance, and we've been given a speed. So what relates speed, distance and time? It is a formula. Speed equals distance divided by time, or in terms of a formula triangle, we have this. Speed equals distance divided by time. We're asked how long did it take to get to Mars for signal. So we want to work out the time. How long means how long time-wise. So time, we cover up, and then we just work out what's left. So time, if I were to cover up the time here, what would be left? Would be distance divided by speed. So t is distance divided by speed. And so what is the distance between Earth and Mars? Well, we're told here it's 3.9 multiplied by 10 to the 7 kilometers. So we can add this in. That's in kilometers. And the speed is in kilometers per second as well. So kilometers are a common feature, so the units are at least consistent, so we're fine. Speed is this. So seconds in, seconds will come out. So divide by 3 times 10 to the 5. So now, on the calculator, I think I'm slightly unorthodox here. Many teachers will tell you to use this button. Nowadays, I think this button is more or less obsolete. We can type it in exactly as it looks using the power button. So we have here powers of 10 and a fraction. So press the fraction button. So on top we have 3.9 multiplied by 10 to the power 7. At the bottom we have 3 multiplied by 10 to the power of 5. Press equals, and we get 130. And so that distance, so that's time, is going to be 130 seconds. So just over 2 minutes to get to Mars for signal. Now for part B, it says the speed of a signal sent from Earth to Mars was actually less than 3 times 10 to the 5, so it was actually sent slower. So if a signal wasn't travelling as fast, how will this affect the answer to part A? Part A told us how long it would take to get there. If something travels slower, it will take longer to reach its destination. So our answer from part A will be greater. So the answer from part A would increase because the time would be longer. So the answer from B would be greater or bigger. Something along those lines would be absolutely fine to say. Question 12. So we've got Patrick here trying to work out the exact value of 64 to the power a quarter. Patrick says a quarter of 64 is 16. So 64 to the power a quarter is 16. He's just thinking that this power is the same as doing a fraction of the amount. So that's wrong. What I'd say is probably explaining in words what's wrong and also giving the correct answer just to absolutely beat the examiner over the head that you know exactly what this means. So there's no doubt in the examiner's mind that you, the candidate, think, oh right, so you know, she knows or he knows what this means. I'll give them the mark, no problem. So what's wrong with what he says? So I'd say something like, Patrick needed to raise 64 to the power of a quarter. Not do what he's done. Actually, I won't put do. Do is a bit simple. Not to calculate so essentially 64 to the power quarter. Let's just say what it is. So 64, press a power button. They can do a fraction within this as well if you want to. So 1 over 4, press equals. So that's about 2.83 to 3 significant figures. So certainly not 16. So that's just explaining why he's wrong and also giving the correct answer. So Patrick will learn better in future. Naughty you, Patrick. Question 13, we have a question about density and mass volume. So we're told about densities and the volumes, but we're not actually told as such the density of antifreeze. However, we need to sort of realise and notice that grams, which I mentioned, are a measure of mass. So you need to remember the formula that relates density, mass and volume, and there is a formula triangle for that, which is as follows. So if I just bring this up here, we have that. So what we're going to do first of all is consider the ethanol separate to the propylene. So for the ethanol, we know the density of the ethanol is this. We also know the volume of ethanol, which is 60 litres. So no density and volume for ethanol, and indeed for the propylene as well. So for the ethanol, we can work out its mass. If we just cover up mass here and see what's left, we just have D and V at the bottom. So mass equals D and V together, which means D multiplied by V. In other words, density multiplied by volume. So in this case, the mass of ethanol is 1.09 multiplied by 60. So we can work this one out fairly straightforwardly. So 1.09 times 60. That gives us 65.4. So 65.4 grams of ethanol. We can then do the same for the propylene. So for propylene, the mass of propylene is once again the density of the propylene, which is, whoops, wrong colour. Density of propylene is 0.97 grams per cubic centimetre, and the volume of it is 128 litres. So just like we multiply the density of the ethanol by the volume of ethanol to work out the mass of ethanol, we can multiply the density of the propylene, 0.97, by the volume of propylene to work out the mass of propylene in the mixture. So 0.97 multiplied by 128, that's going to give us 124.16. Now from these two, we can then work out what the total mass of this mixture is, because we want to work out the density of the antifreeze. And the antifreeze is just the ethanol and propylene mixed together. So from these two calculations, the mass of antifreeze is going to be the 65.4 added to the 124.16 So we've got 124.16 already. If I just add on 65.4 to that, I get 189.56. And also, we know the total volume of antifreeze. So volume of the antifreeze is going to be the volume of ethanol mixed into it, which was 60 litres, plus the volume of propylene mixed in, which is 128. And 60 plus 128, that gives us 188 litres. And from these two, if we know the mass of antifreeze and the volume of antifreeze, we can work out the density of the antifreeze. So therefore, the density of the antifreeze D for density, so cover that up, we'd only be left with M on top and V on the bottom. M on top, V on the bottom. So the mass of antifreeze is 189.56, and the volume of antifreeze is 188. So how accurate do we do this answer? We need it to 2 decimal places. So if we just now input these values and round accordingly, so 189.56, and we divide that by 188, that comes out to 2 decimal places as 1.01. Not 1.00, because next to this final 0 is an 8. So that 8 forces this 0 to round up to a 1. So we have 1.01, and don't forget the units, grams per cubic centimetre. And that's our final answer for number 13. Question 14, we have an area question. An area question which relates to geometry of simple shapes. So we've got a rectangle ABDE and 2 congruent triangles AFE and BCD. Now, importantly, we're told that the area of ABDE equals the area of AFE plus the area of BCD. AFE and BCD are both 2 congruent triangles. So I'm just going to call this here, these 2, added together. That's the same as 2 lots of area AFE, because AFE is the same as BCD. We now need to recall the formula for the area of a triangle. Obviously it's not half base times height I'm on about here. That is the basic formula for the area of a triangle if we know the base and perpendicular height. But in general cases it's going to be half 𝑎𝑏 sine c. So if you know 2 sides of a triangle, you're going out the area of it by doing half of one side times the other multiplied by the angle in between. So what I'm going to pick for this one now, I'm going to pick for 2 sides as follows. I'm going to pick A as AF, which we know. I'm going to pick B to be AE, which is actually what we want to know. And I'm also going to pick the angle C, the angle in between. Well, I'm not going to pick it because it has to be the angle in between the 2 sides. I'm going to pick that to be 30 degrees. So let's now put this information into practice. So the area of the rectangle ABDE, that's just going to be the base of it, which is ED, multiplied by the height, which is AE. So I'm going to say that's AB multiplied by AE. So the rectangle is AB times AE. And that's going to equal 2 lots of the area of AFE. So that's 2 times this here. So 2 multiplied by this here is half times A, which is 24, times our B, which is AE, times sine 30. And what we can do here is obviously neaten this up. So I'll just colour code it so you can see where all the numbers have come from in case you're unsure. So I said A was 24, I said AE is for B, and C is this angle in the middle of AF and AE. So middle of A and B is the 30. So I'm just going to colour code those in just in case. So like I say, neaten this up. 2 times a half is 1. So 1 times 24 times AE times sine 30. So here I'm just going to get 24 times AE times sine 30. But over here, we can use information in this ratio to work out what AB is in terms of AE. And so we're not really interested in AB. We're not interested in this here. We just want to work out what AE is. So from this, the ratio of AB to AE is 1.3. That means that AE is 3 times bigger than AB. And another way of thinking about that is that AB is only 1/3 of AE. So I can use this to write AB in terms of AE. Because AB is 1/3 of AE, I can say that AB is 1/3 of AE, because of operates like a multiply, and obviously times by AE, like so. Now this can be further neatened up. So 1/3 times AE just means 1/3 of AE squared. Now 24 times sine 30, I could simplify this further as well, because sine 30 just so happens to be one of these exact trig angles, gives us a half. So 24 times a half, that gives us 12 AE. So if I multiply both sides by 3, to get rid of this 1/3, so just times in by 3 on both sides. I can see that AE squared, which just means AE times AE, I'll explain my writing like this in a moment, equals 36 lots of AE. Writing it like this allows me to quite easily see that because I've got an AE on one side and the other, I can cancel off an AE on both sides. Therefore we see that this side AE must equal 36. In other words, AE is 36 centimetres. And that finishes off the question nicely. So not the easiest one, but if you think it through carefully and reason it out, it is doable. Question 15, we have a transformation of functions question. So we have a curve C with equation y equals fx, and it's transformed to give a curve S with equation y equals f of minus x minus 3. And so we need to think about what to do first. So we've gone from f of x and 2 changes have happened. Instead of f of x, it's now f of minus x. And also, we've got f of minus x minus 3. So one change here inside the brackets, and another change of this minus 3 outside of the function brackets. So we need to think about the steps to take. So first of all, we had y equals f of x. So what to do first? Well, it's very much like BIDMAS this. And so we focus on the inside of these brackets first, what I call the function brackets, and then everything else comes after. So we work out the brackets first and deal with that change. And so the brackets have changed from f of x to f of minus x. So that's the first thing we'd change in terms of our order of operations when it comes to transforming functions. Then the plus or minus a number, very much with BIDMAS, addition and subtraction comes last. So we'll do this minus 3 bit first. So after getting to f of minus x, the second and last thing we'd do would be to go from f of minus x minus 3. Now, this minus x, I want you to think of this as minus 1x. Now, when the change happens inside of the function brackets, what I tell my students is inside, help if we could spell, inside equals opposite. So it works opposite to common sense. So here, it looks like the x-coordinates are being multiplied by minus 1. But actually, you need to consider it in terms of the opposite. So the opposite of multiplying would be dividing. So to go from f of x to f of minus an x, because it affects the inside of the brackets, it affects x in an opposite to common sense way. So we need to think of this as the x-coordinates are divided by minus 1. X-coordinates divided by minus 1. Now, in the same way, if you had to say f of x to f of 5x, instead of multiplying by 5, we'd be dividing by 5, and so on. So the x-coordinates get divided by minus 1. So in terms of our actual coordinate here, we're talking about 7 and 2. So in terms of our actual coordinate, we're going to divide 7 by minus 1. So then we get minus 7, 2. Now, this change here outside of the brackets, this minus 3 is outside of the function brackets. When it's outside of the function brackets, it affects y in an obvious way. So it affects y in a common sense way. So here, for y coordinates, we just do what it looks like. We subtract 3 from the y coordinates. So I can just write this in. So in our case, we subtract 3 from 2 because 2 is our y coordinate. So subtract 3 from 2. So then 7, 2 goes to minus 7, 2 when we multiply the 7 by minus 1. And finally, we take this 2, subtract 3 from it, and we get minus 1. So in other words, this 0.72 gets mapped to Q, which is this point. So Q equals minus 7 minus 1. So very much like BIDMAS, we divide by minus 1 first, the x-coordinates, and subtract 3 from the y-coordinates second. Question 16. Here we have a quadratic sequence. Okay, so what we need to consider here is the general form of a quadratic. So the general form of a quadratic is ax squared plus bx plus c. That's for like a quadratic graph, or that's if the values are continuous. So for a quadratic sequence, we can alter this ever so slightly in terms of n and the nth term. So the nth term, pretty much the same as this, is an squared plus bn plus c. Now teachers have different ways of teaching this. I'm just likening it to a quadratic graph, ax squared plus bx plus c. That's the general form of a quadratic, normally y equals this. So here, we can just think about what values we've got. And so, minus 1, that's the first term. So that's n equals 1. 5, that's the second term. N equals 2. And the third term, 15, that's n equals 3. So what I'm going to do here is 3, 2, 1. So the third term, second, and first. So like I say here, the general form for the nth term of a quadratic sequence is an squared plus bn plus c. So I'm going to start with the third term, and you'll see how I'm doing it in reverse order, 3, 2, 1, in a moment. So I've got a times n squared, which is going to be 3 squared, plus b times 3, because again it's the third term, then plus c. So in other words, 3 squared is 9, so that becomes 9a plus 3b plus c. For the second term, when n is 2, the nth term is a multiplied by 2 squared plus b times 2 plus c. So 2 squared is obviously 4. So we get 4a plus 2b plus c. And for the first term, n squared is 1, n is 1, so we just get a plus b plus c. So what we're going to have here is simultaneous equations, different ones to solve. So here we've got the top equation and the middle one. So if we do this one, take away the middle, what we'd get is, in fact, before I continue, I'm just going to mention what the third term actually is. So of course, so the third term, when n is 3, this must equal 15. The second term is obviously 5, so I can say this is equal to 5. And the first term is obviously just equal to minus 1. So I can change this to minus 1. So now, like I'm trying to say, we've got 3 different lots of simultaneous equations to solve. So if I look at these first two here and do the top one, subtract the middle, I'd have 9a take 4a, which gives me 5a. 3b take away 2b gives me 1b. c take away c, the c's cancel. I then get 15 minus 5, which is 10. And likewise, if I do the same with these two equations, the middle and the bottom, and do the middle one subtract the bottom, 4a minus a gives me 3a. 2b take away 1b, just leaves me with 1b. And again, the c's cancel. c takes c as nothing. And 5 minus 1 is 5 plus 1, which is 6. Then I can go again, and the whole thing just cascades down and cancels. So again, this one take away that one. 5a take 3a gives me 2a. The b's cancel, and 10 take 6 gives me 4. So therefore, a equals 2. So if I substitute this back into either one of these equations here, so if a is 2, and I substitute it back into, say, this one here, then what I'm going to get here for this one is 3 times 2 plus b equals 6. Times 2 plus b equals 6. Now 3 times 2, of course, is just 6. So this tells us that b must be 0. And finally, we can substitute that a is 2 and b is 0 back into one of these starting equations. So if I were to pick, for example, this one here is probably the easiest. A is 2, so 2 plus b, which is 0, plus c equals minus 1. Therefore, c equals minus 1 minus another 2. c must equal minus 3. So therefore, that tells us that the nth term is, because a is 2, we've got 2n squared. b is 0, so bn is 0, and c is minus 3. So we get 2n squared minus 3. Question 17. This is a simple matching activity. Now, it's only simple if you know them. So the graphs represent 4 different types of function f. So I'm going to have a look at a first of all. Now, we need to match each description of the function in the table to the letter of its graph. Now, graph A, now this is either going to be a cubic graph, that looks like a cubic, it's got an S shape. Is a cubic one of our options? No, it's not. It's not an inverse proportion one. However, it would be a trig function. This is a graph of the type y equals sine x. It might not be sine x, it might be 2 lots of sine x, but it's a sinusoidal curve. When x is 0, y is 0, and it keeps going on and on and on. And if you carried on x going more than this value or less than this one, it'd keep waving up and down, up and down. So this one here, graph A, is a trig function. So we can put this here for A. Inversely proportional, that's when we have asymptotes, where the graph goes really, really steep towards infinity and goes really, really really, really flat as though the gradient's going to approach 0. And so that's going to be graph B. Graph C is a parabola on its side. x squared is either a u or n shape. A parabola laid down is a square root graph. So that just comes from inspection. You get used to seeing them. That's a square root graph, so that's C. And graph D is a exponential function. So reading down, we have B, A, D, C. Question 18, we need to expand three sets of brackets so that we can prove that these three brackets expanded out can be written in the form ax cubed plus bx squared plus cx plus d. A, B, C and D are just whole numbers which might be negative, in other words integers. However, because all terms here are positive, A, B, C and D will all be positive as well. So there are two main ways to do this. What we need to do first of all would be, I would suggest, to just expand two of these brackets and leave one bracket alone. So I'm just going to split the screen into two for now, and I'm going to show you both ways this can be done. So I'm going to call the first way, rather unimaginatively, method A, and I'll call the second way, you can probably guess, method B. Now, it doesn't matter which way you prefer, and you only need to be comfortable with one way. My preference would be method B, but some people might want to expand these first two brackets out first. Okay, and if we do that, what we're going to get is 2x plus 1, x plus 3, expanded first, and we can leave the 3x plus 7 alone. So, like I say, if we just expand these first two, you can use what's often called the FOIL method, or the crab claw method, or just, as I would prefer to do it, simply the first term multiplied by the other two, and then the last term multiplied by the other two. So if we did that, the 2x multiplied by the x would give us 2x squared, 2x multiplied by 3 would give us 6x, then 1 multiplied by x plus 3, well 1 multiplied by anything just keeps the numbers as they are, so then you get plus x plus 3. And then we can neaten this up and then multiply all that by 3x plus 7. Oops, sorry about that. So here, the 6x and the x can be simplified into 1. So that's 2x squared plus 7x plus 3. Multiplied by 3x plus 7. And now we can just simply multiply each of these terms by each of the terms in the second bracket. So first of all, I'm going to multiply the 2x squared by the 3x and the 2x squared by the 7. 2x squared multiplied by 3x, well 2 times 3 gives us 6. X squared multiplied by another x gives us x cubed. And then 2x squared multiplied by 7 gives us 14x squared. Now we can move on and multiply the 7x by both the 3x and the 7. So 7x multiplied by 3x, that'll give us 21x squared. And 7x multiplied by 7 gives 49x. Then lastly, we can just multiply the 3 by the 3x and the 3 by the 7. 3 multiplied by 3x gives 9x, and 3 times 7 gives 21. And the last thing to do is just to simplify all terms. So if we do that, we're just going to get 6x cubed. In terms of x squareds, we're going to get 14x squared plus 21x squared. That gives us a total of 35x squared. 49x plus another 9x gives 58x's. and finally just for 21 at the end. And so that's method A. Now my preferred method would be to, instead of multiplying these last two together, to multiply the first two together, would be to multiply the last two, I mean to say. So this method here, we're going to leave the first bracket on its own and work sort of back to front. And we'll get the same result at the end, it's just a different way of doing it. So here we multiply the first two and arrived at this, whereas here we're going to multiply the last two and leave the first bracket on its own. So here x times 3x and x times 7. So x multiplied by 3x gives 3x squared. X times 7 gives 7x. 3 multiplied by 3x we do next. So 3 times 3x is going to give us 9x. And finally, 3 multiplied by the 7, of course, gives us 21. Next, we're going to multiply all of this last expanded lot of two brackets by the 2x and by the 1 in turn. So the first is multiply the 2x by each of these terms. Now, I'm just going to skip ahead here. Now, 7x plus 9x, that's 16x. In fact, what I'll do, rather than being slack, I'll just show you that extra step. Otherwise, it might look a bit confusing. So, apologies. 2x plus 1, and then 3x squared. 7 plus 9x is 16x's altogether, and plus 21. All right. So now 2x multiplied by 3x squared, 16x, and 21. So 2x multiplied by 3x squared first of all, that's going to give us 6x cubed. 2x times 16x, well 2 times 16 is 32. X times another x gives us the x squared. And then 2x multiplied by the 21 is going to give us 42x. And finally, multiply 1 by all of these terms. So multiplying everything by 1 just keeps everything as it is. So we just get 3x squared plus 16x plus 21. And again, if we simplify all this down, 6x cubed, that's the only x cubed term we have. The x squared terms, 32 of them here, plus 3 here, that gives us 35x squared. The x terms, 42 of them here, plus 16 there, that gives us 58x's. And finally the constant number at the end, plus 21. So we get exactly the same result, just doing it a different way. So pick your own approach. Either way is just as good as the other. Let's have a look now at question 18 part B. 18 part B, we're asked to solve 1 minus x all squared is less than 9 over 25. So what we can do, something squared is always positive. So what we can do here is we can take the square root. So if we square root both sides, so square root this one and square root that one. 1 minus x all squared just leaves us with 1 minus x. Now, because we're square rooting something, we need to consider both plus and minus options. So one possibility is that 1 minus x is the square root of 9 over 25. Or we could have maybe 1 minus x is less than the negative square root of 9 over 25. So actually, we've got two different scenarios going off here. So this is option A, or over here we have scenario B. So dealing with A first, if we just square root the 9 over 25, 9 and 25 are both square numbers. So you can see this on a calculator easily enough. If we square root 9 over 25, we're going to get 3/5. So over here, keeping the symbol the same, minus root 9 over 25 will be minus 3/5. And of course, if you're wondering why it needs to be plus or minus, we need to consider, for example, this equation here. Imagine x squared needs to be less than 36. Then what we could say over here is that x is either less than 6, or, of course, if we square root both sides, we might need to consider where x is the same but minus 6, like so. Now, this being an inequality makes things a bit complicated, okay, because obviously when you're multiplying or dividing by a negative number and you have an inequality, the symbol can switch sides. So my suggestion would be to, just for now, forget the inequality symbol. We'll return to this in a moment. So what I'm going to try and do over here is actually solve something else. Now, this is a general tip I'd use if you've got an inequality which isn't completely trivial. If it's not a linear inequality, if it's something quadratic or cubic, I would suggest, first of all, to find the critical values. In other words, what would make 1 minus x all squared equal to 9/25? So let's first of all solve 1 minus x squared equal to 9/25. So obviously, in this scenario, what we could do is square root 1 minus x. However, what you should know by now is when you square root something, you need to consider both positive and negative square roots. So you need to think about both positive and negative root 9 over 25. Now 9 and 25 are both square numbers, so we can actually square root these. If you see here, if you square root 9 over 25, you get 3/5, because the square root of 9 is 3, square root of 25 you get 5. So 1 minus x is either going to be minus 3/5 or positive 3/5. So let's just consider both cases. So case 1, we have 1 minus x equals minus 3/5. So just considering the first option here, where it's equal to this value of minus 3/5. So what we can do is add x to both sides. We get 1 equals positive x minus 3/5. Then finally just add 3/5 to both sides. We get that x equals 1 plus 3/5. If you do that on a calculator, you'd get 8/5. So that's only one case. Let's now consider case 2. So the other option was the possibility where 1 minus x was positive 3/5. So that leads us on to what I'm going to call case 2. So now we're going to set 1 minus x equals just 3/5. So if we add an x to both sides and then take 3/5 on both sides, we would get that x would equal 2/5. So that's what we're going to pop in now, that x equals 2/5. So those are the critical values when 1 minus x squared is equal to 9/25. What I want to consider next is a graph, a very rough sketch graph of 1 minus x all squared. If you've got something in brackets all squared and it's a positive something squared, it's going to be a U-shaped parabola. So we're going to have something like this. Okay, and I'm going to call this y equals 1 minus x squared. So I'm now going to think about this 9/25. Okay, so imagine this is the line where y equals 9/25. Now we want the curve 1 minus x squared to be less than 9/25. In terms of our very rough sketch, that means that we want the black curve, this 1 minus x squared, to be less than 9/25. In other words, we want this to be underneath, lower than this red line. And so the values we're wanting are actually these ones here. So what we've done earlier is we calculated the critical values of x where x is actually equal to 9/25. Okay, so case 1, we had that x is 8/5, which is here. I'll change that to a black colour. That's from case 2. So case 1, x is 8/5. On the lower side, it's actually equal to 9/25 when x was 2/5. So because we want the value of 1 minus x squared to be underneath this red line, the curve is underneath this red line for x being between 2/5 and 8/5. And so this is our allowed range for x. So therefore, because this inequality doesn't have an equals bit underneath it, we need x to be strictly more than 2/5 and strictly less than 8/5. So therefore, we want x to be between 2/5 and 8/5. We could write it as 2/5 x, 1 and 3/5. It's entirely up to you, but that's that question done. So that's question 18 sorted. Question 19. This is a bounds question. So we've got that d equals u squared over 2a. We're told that u equals 26.2, correct to 3 significant figures, and that a equals 4.3, correct to 2 significant figures. And we need to calculate the upper bound for the value of d. So upper bound just means the absolute maximum that d could be. Now d is given as a fraction, so u squared on top, 2a on the bottom. So to maximise d, to find d max, a fraction's maximised is at its biggest when the numerator is as big as possible. So we want u to be the maximum. So we want to go for u max squared. On the bottom, the smaller the denominator is, the bigger the overall fraction is. So we want to go for the smallest possible value of a on the bottom. So we're going to go for 2a min. So we want the minimum possible value of a. So first off, we're told that u equals 26.2 correct to 3 significant figures. So let's just consider this for a moment. So if we imagine a number line for u, we're told that u is 26.2. So we're told that correct to 3 significant figures at least, it's 26.2. The next number higher than 26.2, which is also to 3 significant figures, would be 26.3. And the one lower than 26.2 would be 26.1. However, to 3 significant figures, it says here that u is nearer to 26.2 than these other two. So what that must mean is that u must be within half of the distance from 26.1 to 26.2, and within half of the distance on the left-hand side between 26.2 and 26.3. So let's just consider what these values would be. So essentially what we're saying here is that u has to be within this range. If it's over here, it would have been 26.1 to 3 significant figures. If it's over here, it would have rounded to 26.3 to 3 significant figures. So on this side, what we're saying is the absolute lowest u could have been is halfway in between 26.1 and 26.2. So the lowest possible u is 26.15. And the absolute highest limit u could have been is 26.25. Now you might be thinking, but if u was 26.25, it would have rounded to 26.3. Well, yes, you would be correct if you said that. However, we're taking 26.25 as the absolute limit. So it's not what it's allowed to be. It can be anything up to 26.25. So imagine 26.249999 going on forever. It can be near as damn it to 26.25. So we're just going to say that this is the absolute and utter maximum. Strictly speaking, it's not allowed to be, but because you can get infinitely close to it, we're going to just go with 26.25. So our u max, the absolute maximum for u, would be 26.25. Now, your teacher may have told you a quick way of doing these boundaries. I'll just explain this so you can hopefully see the logic to it. So we've got 26.25 squared over here. Now we just need to work out what the minimum possible value of a would be. So I'm going to do similar for a. I'm going to do a number line representing a. So a would have rounded to 4.3, correct to 2 sig figs. So a is at 4.3, just as u was 26.2. Whoops, wrong colour. Okay, so I'm saying that a is 4.3. So the next number up, given to 2 sig figs, would have been 4.4. And the other number on the other side would have been 4.2. So because it's rounded to 4.3, that's saying that a must be on the side closer to 4.3 than 4.2. So if we were to split the difference between 4.2 and 4.3, what I'm essentially saying here is that a would have to be at this side of that line. And in the same way, because a rounded to 4.3 rather than 4.4, what I'm saying here is a must have been to the right-hand side of this second line I've drawn. So because I've split the difference, this value here would be halfway between 4.2 and 4.3, that's 4.25. And this value over here would be 4.35. And all we're saying is that A would have to be somewhere in between these two. So that red line represents the range of what A may have actually been before it was rounded to 4.3. We're wanting the minimum value of A, however. So rather than going for the higher limit for A, we're going for the lower limit, which is 4.25. So our A minimum is 4.25. So 2 times A minimum is 2 times 4.25. So all we need to do now is to calculate this with something called a calculator, which I'm sure you've got. If you've not got one of these, I'd strongly recommend you might need one for a calculator exam, unless you've got a super genius intellect. I certainly don't. Lucky you if you have. 26.25 squared, all divided by 2, multiplied by 4.25. Now we want this to 6 significant figures. So 81 of the first 2 significant figures, so 81. Then the next ones, 0, 6, 6, 1 you might think, but after that 1 is a 7, which forces that round to round up to a 2. So 0, 6, 6, 2. So that's our value of D maximum, correct to 6 significant figures. So, for part B, we're told that the lower bound for D is 78.6003, correct to 6 different figures. So I'm going to write this as D minimum. So the lowest value of what D could be is 78.6003. And if I just remind us of what D maximum was from before, let's get the calculator again, 81.0662. So by considering bounds, write down a value of D to a suitable degree of accuracy. So what we're going to do here is we're going to go for the largest degree of accuracy we can, where if we rounded both D min and D max to that same degree of accuracy, both answers would be the same. So for example, if we rounded them to 2 decimal places, sorry, to 2 significant figures, D min to 2 sig figs will be 79. Two significant figures essentially means to the nearest whole number. D max would be 81. 79 does not equal 81. So we can't round it to 2 significant figures because the lower and upper bounds would not agree. So for example, we can't say, we couldn't say that D is 79, because actually if D was on the higher side, D might be 80 or 81 to the nearest whole number. However, if we did it to just 1 significant figure, in other words, the nearest 10, because the first significant figure here is in the tens column. So D min, that's 7, which represents a 70, would round up to an 80, because the 8 is 5 or higher. So D min would round to 80. And D max, which is about 81, to the nearest 10, is also 80. So we'd both round to the same if it was to one significant figure. Therefore, we're going to pick that D is 80. So we're going to go for D equals 80. And the reason is that D min and D max both round to the same value, which is 80, if rounded to one significant figure. And that would probably do. You could go on and explain that that's the maximum accuracy they'd agree. If they'd agree to two significant figures, you'd go to two significant figures. But the maximum we could go to, sadly, which isn't very accurate at all, is just one significant figure. That's the maximum rounding, the maximum accuracy of rounding we can go to where they both agree. Any more, two significant figures or above, they disagree. So they only agree when rounded to the nearest 10. So that's a suitable reason for question 19, and that finishes off that particular question. Number 20, simultaneous equations, but not standard ones. This one is where we have a linear equation at the bottom and a quadratic in the top. When we have a mixture of linear and quadratic, we can't use the process of elimination. We can't multiply the top or the bottom by something, then either minus or subtract one from the other. We need to substitute either an x or the y in the linear equation into the quadratic. Now the choice is yours. You can use either x or y, but the main thing is what we need to do is to get either x or y as a subject of this equation. Like I say, it doesn't matter. What I'm going to do, I'm going to aim for getting x as the subject. So if we start with this bottom equation and subtract 4y from both sides, we would get 3x is 7 minus 4y. If we now divide both sides by 3, we get x as a subject, which is what we want to have. So we have x equals 7/3 minus 4/3 y. Now what we need to do is we substitute this expression of x into the top equation. So now we've got this, we pop this into the top equation. So the top equation now becomes x squared, but x is this. So we get 7/3 minus 4/3 y all squared minus 4y squared equals 9. So this is going to get a bit ugly, but we just need to expand out this expression for what is x in terms of y using what we know from this year's teaching. So if you're expanding out a binomial bracket squared, a bracket where you've got two things in it, and we times it by itself, we multiply the first thing by itself. So first of all, we do 7/3 squared. And we could do this on a calculator if you want to, but 7/3 squared, we square the top, which gives us 49, and we square the bottom, 3 squared is 9. We then take these two terms, we multiply one by the other, and double. So we do 7/3 times minus 4/3, and then we double that result. So 7 multiplied by minus 4, that gives us minus 28. If we double that, we get minus 56. And 3 multiplied by 3 is 9. But because we're timesing here, it's a term in terms of y, we need to include the y at the end as well. Finally, the last term squared, 4/3 y multiplied by 4/3 y. So we square the number. 4/3 squared is 4 squared, which is 16, over 3 squared, which is 9. And then we do y squared, which we just write down as y squared. Then of course minus 4y squared, that equals 9. Now this obviously looks something of a mess. So what we could do with doing is to get everything onto one side equaling 0, so that we then have a quadratic, so we can solve for y using the formula. We could complete the square as well, but I would suggest using the formula would be easier. So first of all, what I'm going to suggest we might want to do, this is a suggestion purely, to get rid of the fractions, what we could do is multiply both sides by 9. So multiply everything here by 9, multiply the right hand side of the equation by 9. That gives us 49 minus 56y plus 16y squared. All these 9's on the bottom will cancel. Then 4y squared times 9 is 36y squared, so we have minus 36y squared. That'll equal 81, because 9 multiplied by 9 is 81. So simplifying, if we subtract 81 from both sides, then 16y squared minus 36y squared, that gives us minus 20y squared. 49 minus 81, may as well be careful and use a calculator on this. So 49 minus 81 gives us minus 32. And then of course you have this minus 56y. That equals 0. Next, my suggestion would be to make this a bit simpler. So I'd suggest multiplying it by a negative to get the y squared term and all the other terms as a positive. However, we could also, if we look at these numbers here, all of them are factors of 4. So we could divide by minus 4 on each side. Obviously 0 divided by minus 4 will just stick at 0, so we can do that very easily. So if I just give myself some more space and bring it over here. So minus 20y squared divided by minus 4, that will give us 5y squared. I'll put the 56y first actually. So minus 56y divided by 4, that's going to give us positive 14y. Then finally minus 32 divided by minus 4. So I meant to put minus here, my mistake. That will give us positive 8. At this stage we can use the quadratic formula. So the quadratic formula goes x, or in our case y, equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2 lots of a. So now we need to remember what the a, b and c mean. Well, a is just the coefficient of the squared term, which in our case is 5. B is the coefficient of the y term, which is positive 14. And the c, which we have at the end, c is the constant term, which here is just positive 8. So we can use this to solve for y. So therefore y equals minus b, that's minus 14, plus or minus the square root of b squared, that's 14 squared, minus 4 times a, which is 5, times c, which is 8. All of that divided by 2 lots of a, which means 2 lots of 5. And again, just to colour code it if you want to understand where the numbers are coming from, but hopefully you can see this. And then obviously the b was 14. So if we just bang this into our calculator and see what we get. So minus 14 We'll do plus first, plus for square root of 14 squared minus 4 multiplied by 5 multiplied by 8, all divided by 2 times 5. We get here minus 4/5. And so one option for y is minus 4/5. For quadratics, there's often 2 roots, so we'll press again. But this time, all we need to do is oops, that's messed up, but never mind, I'll put it back in. This time, going for the minus root. There's a way where you can toggle back and just change the plus to a minus, but I fluffed that one, but never mind. Minus 4 times 5 times 8. So I'm just putting in all the same, but just changing this plus to a minus. And that one we get minus 2. So y is minus 4/5 or minus 2. So now we need to solve for x. So we've got 2 different options for y. So we'll go for when y is minus 2 first. So when y is minus 2, we can use this equation for working out what x is when y is minus 2. So from before, we worked out that x is 7/3 minus 4/3 y. So we can compute x using this. So x is going to be 7/3 minus 4/3 of y, which is minus 2. That'll give us a corresponding value of x when y is minus 2. So we just have to type this in. So 7/3 minus 4/3 of minus 2. Just be careful to put the minus in. That comes out to be 5. So when x is minus 2, y is 5, and that's one solution pair. The other solution pair we work out when when y is equal to minus 4/5. So what happens when y is minus 4/5? So using the same equation, we would get that x is 7/3 minus 4/3 of minus 4/5. Just plugging in y as per this expression here. So in the same way as before, just with a different value for y now. So I can just change here this minus 2 to a minus 4/5. Whoops, not like that I can't. So times by minus 4/5. And that gives me 17/5, which if I wanted to, I could change into a mixed number. So if I want to press shift this, I get 3 2/5. But it's up to you. You can leave it as 17/5 or 3 2/5. You could even, if you wanted, put it as a decimal. So you could even write 3.4. It really doesn't matter. I'm going to leave it as 17/5. So therefore, solutions are twofold. So we've got x is 5, y is minus 2, and also we have a solution pair of when x is 17/5, y is minus 4/5. And that finally, after quite a bit of hard work, is question 20 done. Question 21, we've got this histogram, giving information about the distribution of the weights of some onions grown by a farmer. So onions less than 60 grams in weight are used for pickling. Onions greater than 120 grams in weight are sold at the market. The rest of the onions are sent to a food processing factory. We've got a pie chart which shows the proportions of how these onions are used. We need to work out the proportion, in terms of this angle, of onions sent to the food processing factory. Work out the value of x. Well, the main thing to notice here, we have a histogram, which always relates to frequency density. So what's the magic formula for a histogram which relates frequency and frequency density, the answer is frequency density always equals frequency divided by the class width. So the stupid way I remember this is Fat Dad's Feast on Chicken Wings. It's particularly stupid, but it might work for you. Fat Dad's Feast on Chicken Wings. That's how you can remember this magic triangle formula. So let's just break this into different parts now. So first of all, we're told that onions less than 60 grams in weight are used for pickling. So let's consider those. Those less than 60 grams are these onions here, between 0 and 60. Now, we can use this equation here to work out the total number of onions for frequency in this box. So for these ones here, frequency is frequency density. So from 0 to 60, that's 60, multiplied by the class width. Sorry, the class width is 60. I'll get myself confused. Frequency density is this axis going up vertically. The frequency density is 2. So 60 times 2, that's 120 onions. So they're used for pickling. So onions used for pickling, I'm just going to write in 120 here. But onions greater than 120 grams are sold at the market. So again, we need to think about this. So those sold at the market are all those greater than 120 grams. Now that's going to be the end two bars. This very thin, tall one, and this one at the very end. So we've got this bar here, and also the bar at the end. So again, we can use this same formula. To work out the frequency represented by each bar, it's the frequency density multiplied by the class width, or class width multiplied by frequency density, whichever way around you want to think about it. So if I colour code FD in yellow and class width there, we just multiply one by the other. So in this case, the first one we did, we multiplied the class width, which was 60, by the frequency density, which was 2. For these ones here, we can employ the same idea. So this one, this is where you need to be counting these little squares. So how do we do that? Well, I just pick a bar which is easier to read. For example, this bar here goes from 60 to 90, and it goes from 60 to 90 in 1, 2, 3, 4, 5 squares. So 5 squares along must represent a width of 30. If 5 squares represents 30, dividing by 5, 1 square is 6 grams. 1 square is 6 grams. So this bar here is 2.5 squares along. 2.5 squares along is going to be 2.5 multiplied by 6. That's going to be 135 grams there. So 135 take 120. The width of this one is 15. And the class width, the height of it, is 6. So 15 times 6, that's 90. So again, just colour coding how we did that. So frequency density was 6, and the class width was 15. We also need to do it for this bottom bar as well. This one goes from 135 to 180. So the class width of that one is 180 minus 135, which gives us 45. And the density of this is 2. So 45 times 2, that also gives us a frequency there of 90. And so we had 90, which we use for pickling, No, we didn't. What am I talking about? Use of pickling, so we had 120. Now, the ones sold at the market is now 90, and this other 90, which is 180. So at the market, I'm going to put 180 in there. And the other ones in the middle must be the ones sent to the food processing factory. So that's the last thing we need to consider now. So these middle two bars represent the onions that are going to be sent to the food processing factory. So we've got this first bar, and also we've got this bar here, the taller one. So the same procedure applies. Frequency density multiplied by class width each time. Okay, so this one. Frequency density is 5, class width is 30. So the onions represented by this bar is going to be 30 times by 5. 30 times 5, that's 150. And finally, for this bar here, the top one, from 90 to 120, that's a class width of 30, and the height of it, the frequency density, is 9. So the frequency represented by this one is 30 multiplied by 9, wrong colour, 30 times 9, that gives us 270. So 150 plus 270, total those up on your calculator or otherwise, that comes to 420. So now we can work out the total number of onions. So the total number of onions is 120 plus this 180, so 180 plus 120 plus a 420 which has been sent to the processing factory. Can't seem to write, what's wrong with me? 420. So if we add those together, what we get is 720 total onions. Now 420 of those get sent to the food processing factory. So the fraction that gets sent to the food processing factory, so the fraction sent for food processing, that's going to be 420 divided by the total. So 420 divided by 720. Let's see what that gives us. So 420 over 720, 7/12. So proportionally, if 7/12 of the onions go for food processing and the angle x represents the proportion, then angle x must represent 7/12 of the full circle. So therefore x must be 7/12 of the full 360 degrees. Because the fraction sent for food processing was 7/12, so we want that fraction of that circle. So 7/12 of 360 will give us our final answer. So 7/12 of 360, that comes out to give us 210 degrees. So we found x, hence we've solved the question. So we're nearly at the end of the paper now, just 2 more to go. Question 22. We've got a circle, as you can see. So we are told that AB is a tangent to the circle, so it just touches the circle at point A. AB, as we said, is a tangent. Angle OBA is 30 degrees. Point B has coordinates 16, 0. Point P has coordinates 3P and P. So that actually means 3 units along and P units up, whatever P may be. And we need to find the value of P, giving the answer correct to 1 decimal place, showing all working. It may not seem like it initially, but this here is actually going to be a question involving trigonometry. So trigonometry should get you thinking straight away of SOHCAHTOA. It's also a question, because it's a circle primarily as well, we need to remember some circle theorems. What we need to remember here is that a tangent will meet the radius to the circle at a 90-degree angle. So what I can do here is just draw on this red line, which is going to be a radius. So I'll just call this R, because obviously R for radius. And we can set about trying to work out what this radius is. As well as that, we know what the distance from B is from the origin for horizontal distance along, because the x-coordinate of B is 16 units. So using that piece of information, we can label on that this distance here from O to B is 16 units. We also know the angle between OB and AB, which is 30 degrees. So we know this side here. So relative to this bottom triangle, which I'm just going to quickly colour in so you can see which one I mean. Not that there's any confusion, there's only one triangle I've drawn. So just looking here, we can add in some bits of information. So this side here is the hypotenuse, because it's opposite to this right angle, and also opposite to this 30-degree angle here is the radius. So the radius is literally opposite to the angle. So I want to find the opposite. So I can tick the opposite because I want to find this. I also know the hypotenuse, so tick hypotenuse. So which triangle includes the side I know and the side I want to know? Which one includes OB and the radius? It's this triangle here. So for that reason, I'm going to use the SOH triangle to work out the radius. So the radius is opposite to the angle I know. It's opposite to this 30-degree angle. So I can therefore work out the radius. So the radius, which is the opposite side, I just cover up the opposite and see what's left over. So if I cover up O, I have S and H next to each other, which means sin or sine multiplied by the hypotenuse. So it's going to be sine of the angle in question, which is 30, multiplied by the hypotenuse, which is this 16 here. So if we try this, sine 30, very important, close that bracket off, that's crucial. Multiplied by 16, that gives us 8. So now we know that the radius is 8 units, we can use this in the question to help us find what P is. So from O to the point P, that's going to be 8. And we can now think about what P itself is, this little p here. So if I just extend a line down like so, and then think about this triangle here. Okay, so this triangle we've got, I can just sketch out quite quickly. So we've got here point P at the top. So this is our origin, so that's O, that's P. So this distance is P, and that's 3P. So I'm told the opposite side, this angle here, if I just call that theta. I know this is 8, by the way, because that's the radius. And the main thing I want to do is to find this angle theta. Now, I can actually use the tangent function for this one, because if I were to do that, then the P and the 3P would cancel out. So for example, if I were to just write tan theta, T for tan is the opposite divided by the adjacent, which is P divided by 3P. P on the top, P on the bottom cancels. That just gives 1/3. So from this, we can say that theta, therefore, is inverse tan minus 1 of 1/3. Let's see what this gives us. So shift tan of 1/3 and give it to enough decimal places to make sure there's no rounding error. So that gives me 18.4349, I'll give it to. So 18.4349. At this stage, I've got a choice. So because the adjacent side and the opposite side is given in terms of P, I could either use the sine function or the cosine function to work out what P is. Let's just say, and again this is your choice, let's say we go for the sine function. So using this triangle here, sine theta, if I just erase what I hid here, sine theta is the opposite side divided by the hypotenuse. So fill in what we know. We worked out what theta was. Theta was 18.4349. So sine of that angle, 4349, equals the opposite, which is P, divided by the hypotenuse. The longest side is 8. Then if we rearrange this formula, if we just multiply both sides by 8, we'll see that therefore P equals 8 multiplied by sine of 18.4349, and then we've got our answer. So I've got this angle here stored in the calculator. So what I can do is I can just do 8 multiplied by sine of that answer which has been stored. And it comes out to 2.52 and so on. But because I want my answer only to one decimal place, I can stop at just 2.5. So P, to one decimal place at least, is 2.5, but that's all we've asked to be given it to, so we're done. P is 2.5. Finally, the last question on the whole paper, we've got the dreaded bearings. And we have 3 different towns, Acton, Barston and Chorlton, labelled A, B and C. How convenient. So Barston is 8 kilometres from Acton on a bearing of 37 degrees. Chorlton is 9 kilometres from Barston on a bearing of 150. Find the bearing of Chorlton from Acton. So our objective is the bearing of Chorlton from Acton. So that means C from A. So what I'm going to do first of all is join a line from A going to C. Chorlton from Acton, because I'm starting from Acton. You always start the bearing from the thing after the word from, measured from north. So starting north from Acton, I want to find this angle here. So I'm starting at Acton, facing north, and I turn around just enough so I'm facing Chorlton. So this is the angle I wish to find. Now, this is going to be a mixture of a few things. This is going to be both the cosine rule and the sine rule. But before we begin, let's just see if we can work out anything else about these angles. The key thing here is going to be this angle at B. So if I just drop down a perpendicular from B, this might make it clearer. Angles on a straight line add up to 180. So we can therefore work out that this bit here must be 30, because 150 plus 30 makes 180. And then, using the idea of Z angles, vertically, so not vertical opposite, alternate angles, we've got an alternate angle here, which is 37 degrees, which makes an alternate angle with this portion over here. And so if that's 37 degrees, we can say this angle too must be 37. Because alternate angles are equal. That's 37. So that one here must be 37. So the angle at B, angle 𝑎𝑏sin𝐶, is 37 plus 30, which is 67 degrees. So what I need to do here, obviously I need to work out this angle inside the triangle, but I could also work out AC first of all. I know AB and I know BC. So here what we can do is use the cosine rule, and the cosine rule goes as follows. So I'll just write down cosine rule. This is worth knowing. A squared equals B squared plus C squared minus 2 times B times C multiplied by cos A, where A is the side we're trying to find. So the side we don't know is AC. Okay, so I'm going to label AC as my A, B and C in any order are AB and BC. So I'm going to call B AB. I'm going to call C BC. So therefore, AC, which is our A, that's going to be the square root of all of this. So B is 8, so that's going to be 8 squared plus C squared, so plus 9 squared minus 2 multiplied by B, which of course is 8, multiplied by C, which is 9, times cos A. Now cos of A is just the angle opposite to the side A. Opposite to side A is this angle ABC, and like we mentioned before, the angle ABC is 67. So we can now plug this into our calculator and get an answer for what the side AC is going to be. So AC is the square root of 8 squared plus 9 squared minus 2 multiplied by 8 multiplied by 9 multiplied by cos 67. And give it to more decimal places than we need. So I'm going to give this to 5 decimal places, 9.41991. I'll just double check to make sure I've got that written down correctly. Yes, I have. Now we know that A is this, we can now use the sine rule. So this is a tough question, hence why it's at the end. So the sine rule I could do with working out this angle at A. So I know these sides might be confusing. So if that's side A, according to how I've labelled it already, this is angle A. If that's side B, that means this would be angle B, and angle at A is opposite to side C, and so this little angle here on the inside is just going to be angle C. So I can work out what angle C is. The sine rule says that sine of the angle divided by the side opposite to it, which is 9, equals the sine of any other angle inside the triangle. Now we know this angle here is 67, so I'm going to use 67 divided by the length of the side opposite to this angle, which we worked out, that's side A, or AC, which worked out from earlier was 9.41991. So if we now multiply by 9 on both sides and do sine minus 1 of it, C is going to be sine minus 1 of all of this multiplied by 9. So 9 times sine 67, all divided by 9.41991. So I've got this answer stored. As you can see, it's stored there. So I'm just going to do shift sine minus 1, 9 times sine 67, all over my previously stored answer. And I get 61.5789, I'm going to call that. 61.5789. 5789. Now, as you can see, the angle we want, the bearing of Chorlton from Acton, is actually 37 plus angle C. So that's 37 degrees plus 61.5789. So it's 67 because it's 37 because of this one, and the 61.5789 comes from the fact that's angle C, which is this one. So the angle I've just got, all I need to do is add 37 onto it. So I get here 98.578. At this stage, we need to remember that bearings, before the decimal place, bearings need to be 3 figures. Okay, so 98 wouldn't do. We need to say 0.98. So this answer here would be 0.98, then to give it to 3 sig figs, be 0.6. So 98.6 wouldn't actually do, because the whole number part, if it's a bearing, needs to be 3 digits. So I need to include this 0, otherwise the mark will be lost. Really important. 1, 2, 3 digits before any decimal, if there is one at all, that is. So the bearing from Chorlton to Acton is 98.6 degrees. We finish a question and therefore finish the paper. So that question was hard, and I think that whole paper was quite a challenge, to be fair, as well. So I apologise in advance if it seems like I've spent a lot of time going through these questions. I do sort of go on a bit, I know, I've been told that before, but I find it hard to help. Anyway, I do hope you've got something from the video. Please do consider subscribing and leave any comments in the comment section to give me some feedback. So thank you very much for your time. Good luck in your exams, and you'll see me all soon. Thanks very much.